families are circuit? In fact, it is analog circuits, right? The digital logic coming out from analog circuits. That's what it is called, a digital logic families, right? In crisp, or for your quick definition, I can say it's an interface between the digital domain. Don't go in a broader domain, okay? Digital outputs, like what R level is, like AND gate, OR gate, OR gate, and all these things, okay? So digital domain to the analog domain, that's all. So you just interface the last semester's analog electronics with this digital electronics. Then you will get into the digital logic families, right? So now, why I want to interface? That's the first question, no? Right? So why I want to interface? Because in our digital logics, whatever we have performed right from the starting of the class, like we are having observations and we are trying to blend them and then give an outcome, isn't it? So for example, if I take a simple AND gate, back to pavilion, right? What I'm trying to do, I'm taking two inputs, right? I'm trying to blend them and give a combined version of it, isn't it? That means the two inputs are giving an outcome which is the common factor in that. This is what AND is. Like I have a two inputs like this. So what is the output? 0. So we are giving a verdict on two inputs. This is what the AND gate work is, isn't it? Yes or no? So now, if at all I can think about drawing a circuit in this mode, right? It's very easy to understand. Here I have a two input AND gate. That's all. It's very easy. This is a symbol. But what is the circuit level of it? That means what is there inside that beautiful symbol? That's what is the logic family. Okay, so there is an analog circuit inside it. Then who is dealing with the inside work of that and then giving an outcome? So that's how the logic family came into picture. Right. Now, if you can think with the basic analog circuit, like I have started with AND gate. So there in the analog electronics also, you can start with diodes, isn't it? Because diodes are the starting devices, what you have studied, if I am not wrong. You have studied in basic electronics also diodes, I guess. Is it correct, class?
Yes,
Yes.
ma'am.
Yeah. So right. So that time you have studied about switching characteristics of diode very vigorously. I presume that. Okay. So switching characteristics of the diodes, what they tell, it is about the conduction, current conduction, isn't it? So the diode can be utilized to off and on. Like that is the normal language we use. But actually current it can conduct and it can stop it, isn't it? That's the real fact going behind it. Same manner, if at all I can take that phrase into this language, right? That means I want to conduct both. Otherwise, I can stop one and allow one. Otherwise, I can stop both. What are the outcomes? So I can better develop a small analog circuit inside this and do this work, isn't it? Can I do that? Right. Now you can question me, like only diodes cannot work. I need some more support. Yes, support is definitely required in a circuit through passive elements that is available. I'm not counting them. I'm only counting the active devices. I think that you don't have any doubt regarding the active devices, passive devices, because you have already done your analog electronics, isn't it? Yes or not?
Yes, ma'am.
Okay. So now diode, the basic device, active device, what we have studied, along with the some resistances, passive devices, if at all I can nicely arrange them and provide perfect input, right? How the diode will work out, like not single diode. I will try to combine also. Then can I work out this particular level, like this work, like 0 and 1. It is output is 0, 1 and 0. The output is 0, 1 and 1. It should be 1. So I can get this. This is a low. That means I want output to be low. Low means you can put 0 volts or you can put a high voltage, whatever, depending upon the diodes, isn't it? The diode cutoff or cutting voltages or something. Can I blend these two? Yes? Yes or not?
Yes, ma'am. Yes, ma'am.
Yes. Right. Now blending is very easy because it's a pen and paper work, right? But there are practical complications. What are those practical combinations? I mean, practical complications. That comes the actual real study behind these logic families. It's easy. A circuit design for a digital logic is very easy, provided it can attend the practical complications such as point number 1, speed. Point number 2, the noise. Noise I'll explain also. Power. Right? So now, what does the speed means? Speed I am referring to, again I'll show the PPT in detail, I'll just give the crisp output. Speed I am referring to the output with the change in input. I am talking about that speed, right? Nothing much. So I am evaluating this outcomes in reference to the switching action of the analog devices and giving an output. So that's what I'm talking about speed. Now I should have a match, isn't it? I'm using a diodes along with the passive elements and inputs are provided. I should get an output, right? And afterwards I will try to analyze, okay, low value means some 0.2 volts or 0.3 volts, something like that. I can map that. That is a secondary job, right? So how much, how fast or how quick I can get the output. So that is point number 1. Point number 2. Now who is noise? Noise means it is noise immunity. I am talking about noise immunity. How much this particular analog circuit is immune to the noise. Now anyone knows anything about noise? You know about a signal, right? What do you know about noise? Anybody can say, no problem. You unmute yourself and say.
Ma'am, voltage variation due to various radiations in the environment. Ma'am, variation in signal due to various radiations in environment like magnetic field and
So you can say this as the, I mean, as a layman, it is the effect of the signal due to variations. That means unavoidable what circumstances I can say onto the signal, right? Unavoidable means I don't know, the original signal is getting varied. That's what you are telling, isn't it? Is that correct, Ayushman?
yes, ma'am. Yes, ma'am.
Yeah. So now I am talking about that noise is perfect. Absolutely correct. So noise is the variation of the signal. But I am talking about noise immunity. Immunity means this word is now in the COVID time, it's very important. Immune. What is immunity? Means the circuit, whatever you have designed with the passive elements, right, has to have immunity for the variations. Otherwise, your outcome can vary. Is that correct or not? Just imagine if this devices over here undergoes a variation, that means the output signal is not up to the mark, right? If there is a decision making, like it is high or low at the output. So if at all we have variations and makes a high decision as a low decision, then gone case, no? So this is becoming noise prone. But I don't want noise prone. It is noise immunity we require. So hence our design, the analog circuit design, has to have a noise immunity. That means I should keep the noise margins low level, right? This is the second factor which is very much important when we design the logic family. Third factor, power I told you. Actually power dissipation. This word is again very famous in your devices, isn't it? The power, the device got heated up, the power got dissipated. So we have a power loss, isn't it? We have used this word, power dissipation. So these analog devices are prone for heating effects. They are prone for thermal noises. Those are all heating only. So they refer to the temperature effects onto the devices, which will in turn affect the outputs. Right. So that's how we are trying to avoid these particularly mainly these factors and then understand how the analog circuit can be designed, right? So I just gave you a preface with a very basic device, the active device, how I can develop the digital circuit. Now I cannot confine my devices only to diode. We have done so many things. After diode, what did you study?
BJT.
Yes, you have done. So Why can't I use a transistor also? So why? Because transistor is also acts as a switch, isn't it? So I can use that particular characteristics and build my circuit and then make it as a switch also, and then I can put the switching action and work out my digital logic behind it, isn't it? Yes, the circuit is complex. Don't worry about that. We will think about it later. But circuit is complex, 100% true. Then what next? After BJT, what did you study?
JFET.
JFET you have studied. So JFET has so many drawbacks. I think it is a FET family you are talking about, FET family, isn't it? FET family.
Yes,
So
ma'am.
FET has, yes, that's what JFET is there. Then afterwards you entered into the very wonderful creation of that MOSFETs, isn't it?
Ma'am, the video got stuck.
Yeah, you guys are there?
Yes, ma'am.
Oh, yeah.
Yes, ma'am.
Because I told you there is some issue from morning going on. Okay, so now what happened? I was talking about, yes, after transistor, right? You entered into the FET family, and again we got into that MOSFETs, isn't it? You have studied MOSFETs, right? And then afterwards you have studied the MOSFET in a very vibrant way regarding the amplifying actions, switching actions, and the ease of designing, isn't it? And how much prone it is for the noise. Because I definitely know that if at all you are following Sidra Smith, definitely you will be skipping those pages. Towards the end of every design, they will be having some description on noise immunity, power dissipation. These words normally you guys in third semester level you avoid, but in final semester you need to know about these things, because every device is prone or identified or given elevated with this values only. How much it is immune, how much power it can dissipate, how fast is it working out, isn't it? So that's what these particular devices are used. And now what I was talking is they have prepared a combination of different devices, right, and trying to work out all the digital logic behind it, right? Now hold on, I'll just explain you small things. Initially they started with DL means diode logic, because DL was the very preliminary device. Diode is the preliminary device we have studied, active device. So what they did is diode logic along with resistor. I am not mentioning resistors now. Why? Because they are passive elements. Without their help we cannot finish the circuit. Okay, so along with the diode, we have resistors also. With that this logics are worked out, all the logic, and or not, then NAND, NOR, everything. Okay, so that was the preliminary step. Next step, they worked out with transistor logic, right? Transistor logic they have worked out. Okay, now after transistor logic, what we had FET logic. So they told it as MOS logic, right? So MOS means N MOSFET, P MOSFET, everything. Afterwards N and P together they had this CMOS logic also. This is in general I am talking. So this is how the things are developed, right? Now hold on. If at all I will take a small example. If you are trying to design this function, Okay, on an integrated circuit. I'm not, yeah, I can do the minimization, I think. Okay, this, like this. Best. No minimization. Okay, so this is the function. You have to build this particular logic on a circuit. Please try to understand. We will go step by step. AB bar plus C. So I require a NOT gate, I require a OR gate, and I require an AND gate. Is that correct? Is that correct or not?
Yes.
Yes. Now, I will go for only one logic, that is the diode logic. I will not use anything else. That means I will develop an AND logic with using diodes. I will develop how I will develop, that is secondary. First thing is we should understand what on that board we can have. So diode for AND, diode for NOT, diode logic for NOT, and diode logic for OR. So totally 3 logics have worked out. Altogether, the 3 logics have to be on the integrated circuit board. You will agree? Yes or not? You will
Yes,
agree
ma'am.
for that?
Yes.
Now, altogether, how many diodes we will use on the board? It's a matter of interest, isn't it? Just imagine, we are trying to incorporate a small function, Boolean function on a board using diode logic, and behind every gate we have diodes in that. And how many diodes will be incorporated? Roughly around 10 diodes we will use roughly. Is it correct? Along with that we have resistors also. Yes or not? Right?
Yes, ma'am.
Yes. So this is where the great Moore's law has been developed. This is not our finite state machine. This Moore's law is called device law, we will say. The now integrated integrated chip designs you are telling now is based on that Moore's law. The more you are having the active devices onto the board, the complexity is be very high and prone to all these things, right? But the idea of the greediness is there. Still they are incorporating more and more so that I can fill multiple functions onto a single IC, right? But if at all it can overcome all these things and can have an efficient design, then it will work out for not one, for more than one functions, isn't it? But it depends upon the how the designing will be, right? And how the what type of active devices you are taking and how efficient the devices are working. All these are the circuital level problems, right? So now this fellow has proposed a device law. What is the device law? The integration of the active devices onto the IC, I mean onto the same PCB or on a chip has to be increased. Or based on that, they have this. You know what is this? This one is familiar. Who are these? These words are familiar. VLSI, that is familiar, I guess. Is that correct?
Yes, ma'am.
What is VLSI?
Very large scale integration.
But why you don't know what is SSI? Because it's not your era. It is our era. So we started that small scale integrated circuit with a minimum number of devices. Minimum number. Afterwards, I will tell you what is the number limit. Okay, I will show in the day. PPT. Small scale integrated, medium scale integrated, large scale integrated, very large scale integrated. This is how the device incorporation or the device dumping onto the single IC is increasing. That's what this Moore's has proposed. This is called device law. Moore's. Yes. I am back. You can hear me?
Yes, ma'am.
Yes.
I told you from morning there was a problem. Even in my PG class, there is a lot of problems. Okay, so now this is how it is. Like, let me go back to the PPT. At least for some time I can share something by the time this nonsense one is going on. Just a second.
What is this MSI?
Medium scale integrated. Medium scale. Small, medium, large. Same as your what? Apparel sizes. Excel sizes are also there. That is very large. Yes. Is that correct? No. Yes. Just a second. Now, if you can just see this. Okay, I'm not going to discuss on this. I'm just saying this. Just see this. Here, transistor means this was a little. You people can hear or see. Hello? You people can see or hear anything?
Ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am. It's visible.
Visible, na? Yeah. I'm not going to give any overview or anything. So I just wanted to tell integration levels like gate or transistor ratio means what? The number of gates that can be prepared using transistors. Okay, this is a rough idea. Rough idea. It's not actually designed. It's an empirical formulas they have used and then calculated roughly how many transistors can be there. But the same thing we can check for diodes also because diode has been obsoleted now. That's why they started off with transistor. Transistor means it's not necessarily BJTs only. Different types of transistors are available. Okay. So now go ahead. Like see, if at all SSI, small scale integrated circuit, less than 12 gates per chip. Did you see the numerical? Less than 12 gates only. Right? Now 12 gates per chip means, what do you mean by that? So how many logic functions can be worked out? Yes, you guys are there?
Yes, ma'am.
Yeah. Just see. So how many logic how many logics can be worked out with 12 gates, right? So this is a rough count, then it is categorized as small scale integrated circuit. Right? Now, less than 100 gates, then it is called medium scale integrated circuit. Then 1000 gates, it is large scale integrated circuits. 10,000 gates, 100,000 gates and 1 mega gates. What is this ULSI and GSI?
Ultra large.
It can be alpha. Okay, what will be GSI? G was what? Giga? Or is it talking about some grade or what is the G stands?
It
Giga.
can be
What?
giga large.
Giga.
Yeah, that's what. G stands for giga. Frequency spectrum. We are in the frequency spectrum. Please try to understand. We are moving to from giga to tera now. Terahertz. Isn't it? So giga is the one which we are in at present residing. Okay, so now G stands for giga. But anyway, we are not much worried about what they are called. We are much worried about what numerical is the, limited. It is numerically limited, right? So if it is 1 mega gates, right? Now, if you can understand, for a small multiplexer design, it can fall in only like 4x1 multiplexer. Consider. So it falls in what category? Multiplexer. Yes. What happened? I'm talking about a small multiplexer. Yes, Amux design of 4:1. Right. So you have already a overview of how a mux looks. Select lines, then afterwards the end combinations and the output and all. So roughly how many gates are required there? A 4x1 mux. And in which category it goes? Can it be between SSI and MSI? Is that okay? Or it will be in SSI? Yes, you guys are there?
Yes, ma'am.
So is it SSI or MSI? A simple 4 by 1 marks. Oh, you people are calculating. So I can put that in that bold of either in the SSI, in between SSI and MSI, isn't it? Is that fine?
Yes, ma'am.
Okay. So that's what you do. No need to have that excellent and what perfectly calculated values. I am just asking here. We are in a simple discussion now. Okay. Now just see. This is the one what he has predicted. This is the co-founder of Intel. See, Moore. We will say Moore or Moore, whatever it is. He is not the owner of that Moore state machine. Okay. This fellow is different. Right. Now what he told. Just see. Can you what? Analyze this particular one. I'll show you. Just a prediction made by Moore. Okay, the number of transistors to double every 2 years, it seems. This is what he told. So in that case, what is happening? It's only till Pentium 4. Very old one. We are now with what? Intel 5 or Intel 7 or Intel 9, isn't it? Yes or no?
Yes, ma'am.
So you can
Yes,
just
ma'am.
see how the processing will be, processor evolution is, and how many transistors in that, and how much power is required for the processing with the year, with different years. Like it's only till 2000. Okay, so afterwards we will get one more after 10 years of this. Like 2010 we can get another one, then 2020 also we can get. So still it has been increased. It is only a pretty old one. So you can imagine what will be the last levels. Like I think it will be much more. No? Like it has been already crossed. How many zeros also we don't know. Isn't it? For the processing. How the processor has been evaluated. So this is how the digital logic processor has come into picture. And this is called the Moore's law. This is how it is. Number of transistors to double every 2 years, it seems. So just if at all earlier they are using 4 transistors, afterwards they use 16 transistors. Like that they used to double, right? And now we don't know at all. Million? God knows. Right. So now, simple thing. First, in the beginning. So the word starts with the in the beginning. What do you mean by that? Pretty old logic, right? Which has been started and completely obsolete it has been become. That is the diode logic. Okay, so in that the actual motto is we use mostly the characteristics of diode along with the transistors and then work out a simple gate logic there. Just try to understand. Now just see here. First one. What is that? We have a 2 input AND operation, right? And next to that is the analog circuit line there, isn't it? And we have some resistors assisting the diode also, isn't it?
Yes, ma'am.
Yes.
Yes. Now, what happened to this? The option is they have to prepare an AND gate. Okay, so AND gate, is it possible or not? First check that one with the circuit. See, now I require your analog expertise. See, don't see the this side. I not only check this one. Is this working as a AND value? Is it working as a AND gate? That means, see, VA is 0 and VB you give some voltage like positive voltage. So will it be reverse biased or forward biased? And then you can check the output value also. This one also, another diode. It is an open circuit or short circuit. You know, no? If at all it is forward biased, you will replace with a open. You can take it as a silicon diode. In fact, you take it as a silicon diode or a germanium diode, whatever it is. Right? And try to work out, is it working as an AND gate?
Ma'am, how to analyze? Is it working or not?
How do you analyze? So we have to do many options. Simple. See, VA is there and VB is there. Now 2 voltages. Right. Then you take D1, D2, DL and the output. Give the values. So VA is given some 2 volts. Let us consider VB 5 volts. Okay. 5 volts and VB is given 0 volt. So replace the diodes. Diodes, let it be silicon. Then replace the diodes to connect the circuit. Are you getting an output or not? Check it. It's an analog circuit, no? Yes or not? If you get an output, that means it's working. See, circuit is shown. Oh my God, you are very poor in analog.
Working.
See, PA value 5 volts, PV value 0 voltage. That's all. So now I think 5 volts if at all is divided. 5 means plus 5. I have given plus 5. So plus 5 means what? How it is connected to the diode? Starting plus. So it is, diode is like this. So we have a plus symbol. This is how the plus 5 volts is connected. Right? 5 volts plus 5 first. Then afterwards. Then this side it is 0 volts. 0 volt means what? It is nothing bias. So open circuited only. This one. Second one. Then afterwards, this is reverse bias, open circuited. Then what happened? This is only diode. So this is positive. Right, 5 volts. So this will work or not? Yes, it is forward bias and you will get an output. Is that correct? Is that correct or not?
Ma'am, for 0 volt, you have to put ground or it will be a floating point.
Yes, we will definitely. I mean, we are only doing analysis. We are not doing a real circuital work. Just tell me first, I0, what is the output? Is it working? Yes, it is working, isn't it? Because the 5 volts will be going through this. Yeah, you guys are there or not? I have no idea you guys are so poor in this.
Yes, ma'am. There.
So, you guys are there, but nothing you are doing. This small circuit, you are not able to tell what output you will get from this plus 5 volts and this. You are talking about the diode this. This particular one is grounded. That's it. This circuit is not working this side. Only this side circuit is working through the resistance. It will have a dissipation and you will get a voltage. So what some voltage is coming now output. 5 volts is going through this one. So whatever value of R, you will get an output voltage. So you will get something 1. So is it working? VA is equal to 1 and 0. Is it working?
No.
Yeah, that's what it is. No, answer is no. Why? Because this particular, and you change the, you reverse it. You reverse it. What is that? You give VA is equal to 0 and VB is equal to plus 5 volts. Then do the same situation. Whether it will work or not.
Not work.
It will not work. Right? So 1, 1. That means you take, no, 0, 0. That means 0 voltage and 0 voltage. How it is? So 0 voltage, this is out. So only the 5 volts is going on. So it is working. What is happening? Output is coming. It is also wrong. It will not work. So 5 volts and 5 volts. 5 volts and 5 volts. Is it working?
Then also one will come.
Yeah, it will come now. So only for one scenario it is working. So this is working. This is correct. Rest of the scenarios it is giving a wrong. Isn't it? Yes or no? Now
Yes.
what change? Yes. What change you will suggest? See, don't check the what slide. What is written there? Don't check. You just see the circuit only. If at all, for the other cases it is not working, can I say this is a simple circuit for the AND gate? It's wrong. Don't you think so? What is the alternative you can suggest? You tell me. That means with the diode logic, I can't develop an AND gate. Any alternations you can tell me here in the circuit, or anybody can post how a diode with 2 diodes or 3 diodes, anything you can take. It's 2 bit now, so 2 inputs, so you can use 2 diodes only, and you can work or rework, isn't it? So with the diode, can we do a what? AND gate or not? That is what my question is. You guys are there? Yes, hopefully yes. Yes, Hiranmai, what's the input? Salona? Swallow? Am I not there?
Yes, ma'am.
Ma'am,
Yes. You guys are there or not? I'm not
yes,
able to.
ma'am. Yes.
Yeah. So I have taught so many things. So can we design doing some alterations to the prescribed diode? I mean diode circuit. Let me share again because. Yeah. So in this one, the slide is visible like this. So for this one, what changes I can do so that it works as an AND gate? Or we will rule out that diode logic will not work for AND gates. Is it possible? Like, can I make a statement with diode logic? The what AND gate is not possible. Is it correct? What happened, class? Why you are so dull? Analog circuits. Why you are so dull? Analog, you don't have any good grip on that. Abhijit, Nitin, Hiranmai.
Yes, ma'am.
What happened? I was asking a question, no, I mean, quite repeating. Because see, the circuit what provided to the in that slide is not working as an AND gate. I do agree. So what changes I can do for that circuit so that I can make it work as an AND gate? Huh? That way you are not familiar? Okay, all us answered. How many of you have really worked out the problem since addressment? Just from your diode applications, because you have done from basic electronics, afterwards you have done your what? Analog electronics. So you are still like this. So even if I show so many circuits, I just scroll the circuits, you can see how complex they are. So like this you will have the circuits, logic families. So are you able to take this one? Huh? Without any basic or diode knowledge? Yes, this question is for everyone. I want honest answers from everyone. Swastik, Harsh, Aishman.
Yes, ma'am.
So what is the answer like right now? Are you not familiar with the analog version?
Ma'am,
I was trying to ask a simple question. I need to understand how this circuit works. Right. Now I was thinking that I can make it work as a what? This is what the circuit provided. So whatever value, some resistor, some diode and all. Right. This is 5. So I have VA and right. I'm trying to apply these voltages and trying to check whether this is on, off, or whatever it is. I fill up off or something, and then check the output. So, and whatever, if it is having some voltage, like I will give a threshold voltage, above that I will say it is high voltage 1, and below that it is a low voltage. That is very easy, right? My question is, in these 3 cases, it is not obliging the rule of AND gate. But this case, this particular circuit is obliging the rule. Can I do any changes for this circuit so that it works like a AND gate? That is what my question is. Can we do or we cannot? Nobody is full class. Stop the class then. See, even if I start like this, like the real result, you are not able to suggest something. What I can do further? Do you have? Yes, I was asking simple thing. Do you have any idea like how it works, like a short circuit, open circuit, and all? Do you have any idea on this? This type of circuit. You have, no? I am asking which suggestion to make it work like this. I want when plus and 0 applies, output should be 0. What change I can do there?
But it's coming 0 for me.
Yeah.
It's working fine for if I'm checking. for all the out inputs.
Okay, that then why it didn't work like this? See, this is a positive one. This is a plus 5 volts. No? If this is a plus 5 volt, right? So and it is grounded. Okay, so this is plus 5 volt. This is 0. So for plus 5 volt is applied. This becomes reverse bias. This is open. This is also open. This is out. But this is working. No? This path is working. How you are getting 0? Somebody has told.
Ma'am, if one is plus 5, another is 0, then the value voltage or value of X will be 0.
Okay. Is this plus 5 volts or minus 5 volts? Anybody check out on the this?
Plus 5.
What? Yeah, plus 5 or minus 5? Plus 5 volt? You are telling something, please tell. Somebody is telling something. I couldn't. Yeah, who was telling?
Ma'am, for the particular diode arrangement of V and VB, if we consider only that part and analyze everything else later, then at Vx, the voltage at X will be always the least of V and VB.
Okay, so at this X, yes, gone. So at least you are in the track now. So at the X, we will try to analyze, right? And then afterwards, we will decide this diode. Through this one, we will get an output or not, isn't it? So in this case, what is Vx? 0. In this case. Yes, Hiranmaya. Not only Hiranmaya, everybody are there. All have studied. All have studied. Angad, Ankit, Sai Charan, Harsh. What's wrong with you guys? Vivekanand. So help him out. So what is Vx in that first case? 5 volts here and 0 volt here. What is Vx? Calculate. And this is
0.
this is this is ideal diode you take. Better. Ideal diode. This is 0, no? This is 0 volt. Now tell me what will be V naught? If this is also ideal diode. What will be V naught? Value is there or
0.
value is not? 0. How?
0.
How 0?
Ma'am, because there is ground on the other side with resistor, and if there is 0 on here and 0 on there, the diode will either be open or there is no current flowing.
There's a DC source.
The current will flow from the 5 volt to the 0 of the input.
0 of the input. What does that means? What is the 5 volt to the 0 of the input means?
And from VCC to the low voltage input, it will flow the current.
Inside the
And the
current
zero
path.
will be 0.
So I think the current path will take this one. No? Will the current path take this way? No?
Ma'am, if we make both the paths, it's one path has resistance and other does not, and both are leading to 0. So the current will only flow to the path which does not have a resistance.
See, both the paths means, see, this side nothing is there, ma. So this side nothing is there. I have
Ma'am,
left out only with this path, with this circle.
ma'am,
Go ahead.
for the input side, the current can flow back to the input side since for a 0 volt we are using a ground.
For 0 volt, it is not ground. It is 0 appearing here. 0 volt is ground. Who told? Okay, fine. I agree. Right. Let's start. Okay, if it is 0 volt or it's a ground, then the current will take the different path and no voltage is appearing here. That's what Hiranmaya you are telling. Or Ayushman.
Aishman.
Yeah, Ayushman. So that's what is okay. So I agree. I like it. Right? So if you take the path this way, like the current will not take the this side path, it will take the low resistance path and it will go to 0. Both sides it is going to 0 because here 0 volt applied, it becomes an open circuit and this one is of no use. That's what you are telling, isn't it?
Yes, ma'am.
Oh, so let's agree for that. Okay, I have no objection. So this becomes a 0 volt, you are telling. Okay. Then afterwards for this also the same scenario works out, I think. Then it
Yes,
is 0
ma'am.
volt. Okay. This is also 0 volt. Okay, I agree. This one anyway it's absolutely correct. Hold on. Now the next workout is I need a NAND gate in that. That's what is there in the slide. Just check out. In the slide, what is shown? There is a NAND logic. I want a NAND. Can I prepare the same thing for a NAND logic with a diode zone? See, AND is worked out. Consider what? AND is working out 100%. If at all we apply NAND logic instead of AND logic, what changes I have to make in this? Right. So now just think. If at all we have a logic diagram, okay, AND gate or gate. Okay. So for you, I'll just give one small assignment or some small work. AND or not NAND NOR. All these things use diode logic and give you the circuit. All two inputs only, not as one input. Okay, so all are two inputs only. So already started with this. All started off with this and only diode logic I want. Use your internet sources or but I will analyze it. But try to analyze it. Okay? Try to analyze it and then give me. Is it possible to develop all these values through the diode logic only? If we have this diode logic working out, we will now move to next level is transistor logic. Why? Because there are some lacunas here. Then they introduce the transistor logic. But we have to understand completely what a diode logic is up to. Okay, so same type of circuits you can develop for AND gate, OR gate, NOT gate, NAND gate, NOR gate. So once we have the basic gates already available with the analog circuit, then we will try to mix up and make big circuits, combinational circuits. Is that fine? Yes or not?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
So tomorrow class, I mean, see, you use internet sources. I'm not denying that, but you should be able to explain me just like Aishwan has explained me now. Right, because this is 0 volt considered as ground itself, so it will take a low path and output is 0. Yes, he completely defended that circuit and it works as a diode. Okay, I'm not saying that, I'm not denying that this type of circuits don't work. They do work. Okay, so like that, you build for NAND also, some logic. NOR also, some logic. You combine, no problem. You combine on, off state, anything of the diode. Explore all the characteristics of diode. Right, take the ideal diode itself. Don't even take your silicon or germanium, right? And try to develop this. I want really the originalities to be explained. Like use internal sources, but you should be able to explain that. Is that fine? Tomorrow class, 11 o'clock, the real logic of diode logic of all these basic gates. Anyone, like quickly. Anybody has to work out. Like I don't know, I will call anybody's name. Right. So then after this, they have introduced the next one is your transistor logic. That means this is again completely with the transistors. Right? How the transistor works. Not even a single transistor, they can use more than one transistors. Then also they have started developing the same thing. Now, if at all you check out diode logic and transistor logic, both as devices. Right? What are the flaws of diode and what are the advantages of the transistor? Both can act as a switch, isn't it? Yes or not? Yes. Yes.
Yes,
Now, is the switching speed of a diode when compared to the transistor is different? Because see, our main motto is we have to increase the speed, their noise immunity and what? Power dissipation. So that was the main motto. In that hunt only we have started with the diode. Right? The action of the AND can be performed using the diode logic like this. Same thing if I develop with transistor, we can perform definitely. Circuit can be different. We need not mug up. But when you check these two analog circuits, based upon the output speed, how fast the output is appearing, then we can think that whom to choose. And how the noise immunity level is there, how the power dissipation is there, we can develop the same logic for AND using diodes as well as transistors. Then you can tell that what can be the finalized. isn't it? That's how the transistor logic also has come into picture. Based on the development of semiconductor devices, these digital devices also, digital logics also have been improved. Now, if at all you go to the next level, again there is a mixture. Just see, you have diode, you have transistor together. That becomes the next logic, diode transistor logic. Right. So the same AND gate can be developed using a diode plus transistor and some resistors. So you can check out AND has how many different types. I can develop using this. I can use DTL. I can use transistor logic. They will call it as transistor logic. TTL. DTL means diode and transistor logic. DL means only diode logic. Okay. In every case, resistances are there. So this is just an example I am talking about. Right, and every level they will try to execute what is the, this is afterwards I will tell you how is the voltage and this one is there. So this was the initial ones, right? Before the FET family has been introduced, these are very predominant. These are very predominant. Okay, so diode transistor logic and transistor logic. So all these logics have been utilized to develop the gates. Is that fine? Yes. You guys are there?
Yes,
So
yes, ma'am.
tomorrow I just want the diode logic. I don't want transistor logic. Okay. So I think you have a class next. You don't have a class or you have a class? You have a class? Shweta?
Yes, ma'am. Like after this class?
Yeah, after my class.
Yes, ma'am. We have.
Okay, anyway, tomorrow class from 9 o'clock I'll just see. So please come with the diode logics and try to explain. And if possible, seriously, because this logics, we have to do together. It's not any new thing because it's an old theory applied onto the digital type. So if you want, you can just use a diode transistor logic also you can develop. Only for do one thing. Just a second. Do one thing. Okay, don't go for all. Right? Use for AND gate, DL logic, DTL and TTL. All the three. Three diagrams. Right? And then we will try to discuss. Anyone I can ask. So tomorrow class very crucial. I'll take attendance also. Right? So I can ask anyone, try to explain because you have done already the analog circuits. And it is very important for gate. Okay, so try to work out. Only AND gate you design, not more than that. Is that okay?
Okay, ma'am.
Yes.